All right, everyone. So we've all turned to our notes section. We're recording, and we're going to start our new unit of radicals. Where's the blue? Okay, and Mr. Green, be careful when you sit down. Don't shake the desk. Okay.
Ida.
So here we go. Radicals. Okay. Now I'm going to have a little conversation with you prior. Okay. So everything I write on the board, you're writing in your notes. Okay. So you already titled it radicals unit. You've already put this example in your notes. But I want to talk to you about how this is very important. The connection, okay, from the last unit that we did and to what we're doing now. So it makes it a lot easier for you, okay? So in our unit 6, we were factoring. And we factored like the difference the difference, write this down, of two perfect squares. Okay, so we factored the difference of two perfect squares. 64 is a perfect square, correct? Yes. Okay. Okay, so what we did was when we factored, okay, we said what times what gave us this. And so we said, since this is the difference of two perfect squares, we said, okay, well, what times what gives me the first term, and then what times what gives me the second term. Okay, so we should be writing this in our notes. This is going to be helpful. Well, we know that 64 is a perfect square. That's going to be 8 times 8. We also know that x to the 4th power is a perfect square because it's an even exponent. Okay, so that would be x squared and x squared because 2 plus 2 is 4. And then we know that 81 is a perfect square because 9 times 9 gives you 81. But in order to give you that negative, you have to have a positive and then a negative because a positive times a negative gives you a negative. Okay? So the reason why I'm explaining this to you, and this is important because I want you to see the connections between the prior unit and what we're doing with radicals. Okay? Now, I have to let you know, you guys, this simplifying radicals lesson today, okay, it's going to be broken down into a couple of videos, okay, is the most important lesson of the entire radicals unit. And here's why. Because after we learn how to simplify radicals today, okay, you're going to add, subtract, multiply, and divide radicals, and then simplify them. Okay? So what that means is, you know, you can add, subtract, multiply, and divide radicals, but then if you don't know how to simplify them to get to the simplest form answer possible, then you're going to get it wrong every time. So this is what you do, the lesson that we're learning today, this is what you do after you add, subtract, multiply, and divide radicals. Then you have to simplify to get to the final, the most simplified answer, okay? So that's why this lesson is most important, because if you don't know how to simplify, then all the other lessons that we're going to be doing is going to be for nothing. Okay, because you don't know what to do with it after you add, subtract, multiply, or divide them. Okay? So, let's talk about this right here, radical 169. You guys, the question that you need to keep in the forefront of your mind throughout this entire unit, okay? What the radicand, the question that the radicand is asking is this. What times what gives you the number that's inside the radical? That's the question that you have to ask yourself throughout this entire unit. Okay? So, what times what gives me 169? And by the way, you need to have calculators throughout this entire unit because we're dealing with radicals. Okay? Because if you don't know what times what gives you 169, then you're going to need to use your calculator to figure it out, because what we know, okay, is that if you take the square root of a number and you get a whole number, right? So what times what gives me 169? 13, okay? So when you get a whole number for your answer, okay, you know that the number that's inside the radical is a perfect square. So if you're unsure, then we should know by now how to use our calculators to take the square root of a number. So if you weren't sure if 169 was a perfect square, then you just use your calculator, take the square root of 169, and if you get a whole number, then you know it's a perfect square. If you get a decimal, then it's not a perfect square. And I'm going to explain to you why the perfect square is so important. So now everyone, I need you to take the square root of 155 with your calculators, okay? And we should get approximately 7.4. Now, we got a decimal for our answer, okay? This means that 55 is not a perfect square, okay? So I want to show you the difference. We got a whole number for our answer here when we took the square root, which means that 169 is a perfect square, and we got a decimal for our answer, which tells us that 55 is not a perfect square, okay? So moving on to the examples and how do we do this simplifying radicals. So I want you to go ahead and write the next 3 examples in your notes, starting with radical, right here. Write these 3 examples, okay? Now, we just said that radical 169 is 13, okay? So, let's move on to other things that we can encounter when we're working with radicals, okay? So, here's our negative symbol in front of radical 49. What does that tell us, okay? What that tells us is this. You have to give me the opposite of whatever the result of this is, okay? So, what is the square root of 49? 7. What's the opposite of a positive 7? Negative 7, and you're done. So when you see a negative symbol in front of the radical, that's how you handle it. Take the square root and then give me the opposite of that result, okay? Now we have 2 radical 144. This 2 right here in front of the radical tells me that this is going to be 2 times whatever the result of this is. Okay, so what's the square root of 144? 12. What's 2 times 12? 24, and you're done. Any questions about that? So when there's a number in front of it, that means you have to do 2 times whatever the result of that is. Now here we have a negative variable in front of the radical. Same directions, okay? We said 2 times whatever this is. Well, it's going to be negative x times whatever the result of this is. So what is the square root of 81? 9. What's a negative x times 9 give us? Negative 9x, and that is your answer. Are you all with me? Okay? Yes.
So the original answer was 9, and you just made it negative and put x.
Right, because okay, so let me break it down for you. Okay, so the square root of 81 is 9, and you know that this negative x should be multiplied to whatever the result of that is. So what is a negative x times a positive 9? Well, a negative times a positive makes it negative, and x times 9 is 9x. So that's your answer. Okay, I'm going to erase this and keep going. Okay, so moving down the line. Now I want you to write these 2 examples in your notes. I know we're going to go back to 7th grade, okay, simplifying fractions, but I want you to write this example twice because it's going to explain the process and what I'm trying to get across here a lot easier, okay, which will save you steps and a lot of hassle and such. So if it said simplify this fraction, okay, we look at that and say, oh, okay, what are the multiples of 50 and what are, the multiples of 100? Well, you could say, what could we say? Maybe 10, okay, or 25, but let's go with 10. That doesn't matter. Let's do 10. Let's go with 5. I'm sorry. Let's start off with 5. Okay? They're both divisible by 5. No, let's go with 10. That's fine. Okay, divided by 10. Either way, you're going to get the point. So 50 divided by 10 gives you 5. And then 10 divided by 10 gives you 10. Okay, so every step of the way, actually, I'm going to do it. I apologize, you guys. Let's start with divided by 2. Okay, that's what I wanted to start with, because you guys, it's going to be the case when you use your calculator that you're not going to know what the GCF is. So my advice to you is take your calculator, divide by 2, divide by 3, divide by 4, and go through that process if you don't know what the highest GCF is, okay? So this is what you would do. So 50 divided by 2 gives you what? 25. And then 100 divided by 2 gives you 50. Now you have to ask yourself every step of the way, is this as simplified as I can get? The answer would be no. So you would ask yourself again, what are these both divisible by? And we can say 5 now, okay? So now let's say divisible by 5. Both of them are multiples of 5, so let's do that. Okay, so 25 divided by 5 is what? 5. And 50 divided by 5 is 10. So now, again, ask yourself the question, is this as simplified as we can get? And the answer is no. And I'm doing this on purpose, you guys, because you will have to ask yourself every step of the way when you're doing simplifying radicals, is this as simplified as we can get? Okay? So, no, this is not as simplified as we can get. They're both, once again, divisible by 5, but you'll see the point that I'm trying to make very quickly. So 5 divided by 5 is 1, and 10 divided by 5 is 2. So now we have to ask ourselves, is this as simplified as we can get? Yes. So we stop here. Now, let me show you what knowing the highest GCF will do for you. Can anyone tell me what the highest GCF of these two numbers are? 50. So if you were to divide, watch, everybody write this down in your notes so that you can show and demonstrate the difference. Okay? Because we're going to do this again only with a radical. Okay, so it'll really help you see. 50 divided by 50 is 1, and 100 divided by 50 is 2, and you're done. So I hope you see. Okay, we had to do 1, 2, 3, 4, 5, 6 steps to get there here, which is fine. It's just going to take you a little more time to get there, okay? But it's totally fine if you don't know what the highest GCF is. But if you know what the highest GCF is, okay, sit up please, Marcos. Then you divide by it, and how many steps do we have? 1 step to get there as opposed to 6. Do we all see the difference? Okay, that's a very important point that I need you to recognize. So let's do this. Everyone go ahead and write the next 2 examples, which is radical 125 and radical 200. And I'm going to teach you how we begin simplifying radicals, okay? So I'm going to cover up the 200 for now, all right, and let's talk about this. So what was the question I told you guys that we need to ask ourselves when we're looking at a radical, a number inside of the radical? You have to ask yourself, what times what gives me the number that's inside, okay? But here's what you need to know. And everybody put over here, perfect square. Okay? What times what? Okay, so what you need to do is this. You need to take the square root of 125, and if you don't get a whole number, then that's your clue, okay, that you need to simplify this the way that we're doing it right now, okay? So radical 125. So when you look at this, you have to ask yourself, what times what gives me 125, okay? But one of those numbers need to be a perfect square. So everyone go ahead and draw the radical, and this is I call this the roof, okay? You're going to hear me call it the roof. So you have to draw the radical a little bit longer. So I need to know what times what gives me 125, and one of those numbers has to be a perfect square. Anyone? Very good. Okay, so it's going to be 25 times 5. So everyone write that under the roof. I call it the roof, okay? Now, I want you to draw an arrow to the 25, and I want you to write perfect square, okay, above it. And I want you to draw an arrow to the 5, and I want you to call those in quotes the leftovers. Okay? You'll see what I mean by leftovers in a minute. Okay? So, again, we didn't do anything yet. Okay? We just broke this number. We broke 125 down into two numbers that when multiplied together gives you 125. And we made sure that one of those numbers was a perfect square. You guys, when you write the two numbers under the roof, you have to make sure that you put the perfect square first, and then the number that is not the perfect square second. And here's why, you guys. And I know I've told you to draw arrows. I've told you to draw rainbows. I've told you to draw smiley faces and stars. I'm corny. You know, we're used to this. So I want you to do something else right now. I want you to circle that perfect square and draw an arrow pointing in the downward left direction. And I want you to do this every time because I'm a visual learner. I'm a visual person. And this visually says to you, okay, that you are pulling out, you're doing what the radical is asking you to do. You're pulling out the square root of 25 of the perfect square that's in there. So what's the square root of 25? 5. And then we draw our radical here. And what is still left over? 5. So you guys, this is your final answer. This is as simplified as you can get. Okay? So, any questions about that? I want you to try it with radical 200. Okay? So let's get that down.
Wait, what?
And I'm going to...
Why'd you do that?
Why did I do what, Mr. Green?
The 5, 5.
The square root of 25. We're going to do another example. Pull out the square root. Square root of 25 is 5. And then what is still left over under the roof?
5.
That's why I call them the leftovers. So the leftovers go under the roof. Okay?
So is that a 0.5?
That's a 5. That's not a 0.5.
So you...
This is 25 times 5.
Oh, okay.
Okay? So let's try it again with radical 200. We're going to do it again. So what times what, you guys? Draw a longer roof, because we're going to put the two numbers under the roof. And the first, one of those numbers has to be a perfect square. So what times what gives me 200? But one of those numbers, it's like a puzzle again, like we did with the magic X. It's another puzzle. What times what gives you 200? But one of those numbers has to be a perfect square.
10 times 10?
20.
Okay,
10 times 10?
100 times 2.
Okay.
Isn't 100 the biggest perfect square we can think of?
Mm-hmm.
Yes. Okay, so we circle that perfect square, draw the arrow to signify that we're taking out the square root of 100. Okay, what's the square root of 100? 10. Are you watching, Mr. Green?
Yeah.
Okay, and then what do I put? I put the leftovers under here. So, Mr. Green, this is not 0.2, this is times 2, 100 times 2. So we bring this down, and then 10 radical 2 is your simplified answer for radical 200. Okay? Now I'm going to show you the difference between the power of pulling out the highest perfect square in the number that you're given. Okay? So let's all, and I want you to draw it just like I did in the notes here. Okay? We're going to draw 160. Okay? And this will be our final example for this video. But write 160 and draw the squiggly down the center. Okay? And just like we did with simplifying 50 over 100, the fraction, I'm going to show you the difference between both sides, okay? So we have radical 160. So what times what, eyes up here, what times what gives me 160, okay? And one of those numbers needs to be a perfect square. What comes to mind immediately?
10 times 16.
4 times 40, okay? So, let's do that first. Okay? Is 4 a perfect square, you guys? Yes?
Yeah.
Okay? So, again, circle that perfect square, draw the arrow to symbolize that we're going to pull out the square root of 4. Okay? And so we're going to put it here, 2. And then what is still, remember I called them the leftovers? What is left over? 40. Now here comes that very important question. Are we as simplified as we can possibly get. And you have, in order to answer that question, you have to look at the number that's in the radical, because a lot of you are going to do this when you're first starting out, okay? And you would say no, because there's another perfect square in 40. What is that perfect square in 40? What times what gives you 40? But that one of those numbers is a perfect square. 4 times 10. Okay? So what do we have to do? We have to bring, this is 2 times whatever the result of this is. So we have to bring down our 2. So bring down your 2 and put the multiplication symbol to remind you that this is 2 times this. So 2 times, okay? Draw your roof. So we said what times what gives us 40? It's 4 times 10. We have to put the perfect square first, right? Circle that 4, draw the arrow. What is the square root of 4? 2. So that goes here. And then what is still left over? Radical 10. So put the radical 10 there. Okay, are we done? No, because we still have to do what's going on here. So 2 times 2 is what? 4. So our final answer is 4 radical 10. Now, we have this on the left-hand side. And I think someone said this earlier with what 2 numbers, when multiplied together, gives you 160. And one of those numbers has to be a perfect square. I think I heard 16 times 10. So let's do that. 16 times 10, which is exactly true. And it's exactly what I wanted to hear from you guys. So that's really good. Okay, so is 16 a perfect square? Yes. So that's what we write first. Then we write the leftovers, right? So now we're going to circle that 16. Everybody circle it, draw the arrow, even though it's corny. Get used to it. Yes, fabulous. And what is the square root of 16? 4. And what is left over? 10. 4 radical 10. Look what we got, 4 radical 10 here, and we got 4 radical 10 here. We had to do 2 or 3 steps, maybe 4 or 5 steps here on the left, when we only had to do 1 step on the right. That's why I said that choosing the biggest, greatest common factor, okay, that is a perfect square, the highest perfect square, will get you there faster, okay? So let's shut off this video for now.